Hi, this is Richard C. I'm a math tutor here at Wyzant, and I'm answering a question submitted by a student. This is obviously from geometry. We have kind of a classic drawing here where we have a right triangle, this big one, ABC, and then an altitude is being drawn here, which gives us a right angle on the hypotenuse of the big right triangle. So I'm just going to fill that in. And we need to solve this problem down here. Ultimately, dB is 9, DC is 4, and they want this side, I'll call it H, because that's the height of the triangle. They want to know what H is. Okay, so what we're going to do is we're going to show that these two triangles, these smaller triangles, are similar. And just let's take a quick look at that. Well, the first thing I want to do is just color code them. So we have this triangle here. We'll make that the green triangle. Oops. And then we'll make the other one the red triangle. So kind of a Christmas triangle. Red and green. Okay. So let's take a look at the green one. And I'm going to call this angle C. I'm just going to put a little C in here. And because this is a right triangle, this angle up here must be 90 minus C. This angle here is C. This is 90 minus C. And this is the right angle here, which is 90. So you have 90 plus C plus 90 minus C is 180. Now, because this is a right angle here at the top, A is a 90-degree angle, this has to be C in here. This angle here has to be C, doesn't it? Because after all, actually I should put that in red. Let's just see here, isn't it? Because these two angles have to add up to 90. And then because this left one, the red one, is a right triangle also, this is 90 minus C. So you can see that the red triangle and the green triangle are similar because their angles are congruent. They have the same angles. Okay. So let's write out a similarity statement based on this. We can say that a triangle ACD is similar to triangle, well, what's similar to A? You can see the green triangle ACD. A is not 90 minus C, so A corresponds to B. So these two angles are congruent, so I'm going to write triangle B. Let's see. And then C, the angle C is here, so the C would be up here, so that would be A. And then, of course, we have the other angle in this red triangle is angle D. So angle A corresponds to angle B, because they're both 90 minus C. Angle C corresponds to angle A, because they're both C. Angle C and angle A, and then angle D is corresponding to itself. Okay, so then based on that, we can take these ratios. We can say that AC, we're interested in actually we interested in AC? No, we're interested in BD and DC. So we'll do red is to green here. So BD is to CD. So BD is coming from here, first and last. CD should also be first and last. See, B and A. Let me just make sure B and A are congruent. And A I think I might have this congruent statement wrong. B and A and ACD. Okay, this is red. And then red C is up here, red C. Well, there is no red C. This is green. I'm really sorry. Let me just do this. Just write this as green and red. And I want red over green, so BD over AD. BD over AD. Is the same as the red AD over DC. Red AD is the last two, and this is the last two here. CD, I'll call it. You see that? So the red is BD, the first and the last, over green, which would be the first and the last, AD. And then AD, which would be red, AD, which is the height here, corresponds to CD. AD is the first and the last here, and then, I'm sorry, the second and the third here divided by the second and the third here. Okay, so it just takes a lot to keep track of. And so now we can fill in the values. So BD is 9, AD we're calling H, so H, and then CD is 4. So you have H squared equals 36, so H is 6. And that's all there is to it. So it's just difficult to keep track of all these moving parts, and it's made a little bit more complicated because we repeat this AD in both proportions here. But once you've got the corresponding angles written out properly, so A corresponds to B, C and A, and D, the rest of it just flows from that. You just have to be careful with it. And so that's how we find the height on this right triangle that has an altitude drawn to its hypotenuse. So the name of this theorem is the altitude-on-hypotenuse theorem. And we just proved one part of it. There are actually 3 parts to the theorem. We just used one part of it here. Okay, hopefully that was helpful to you, and I'll see you again next time. Bye-bye.